All right. Okay. Well, welcome everybody to the let's see, what is it? July? Oh my goodness. July 2026 meeting of the Seattle Robotics Society. Good grief.
Yep, half the year's gone.
Sure enough.
This year just started.
Yeah. Yeah. Okay. Usual stuff here. Follow our general agenda. Um, the well, we'll see where the tech topic video goes today, or videos go. So I've got a bunch of some little shorts and other things in there, but it's kind of all clustered around the same general topic. Um, let's see. We got yeah. I'm going to follow our general agenda here, and I'll just kind of start marching through it. So anybody's got any questions about anything, of course, feel free to jump in. And if you're not talking, just make sure your microphone is muted. And I see it looks like everybody is doing that, so that's good. So let's see. Okay, just mentioned that. And let's see. Turn on your chat so that you can see and hear questions that people are typing in over there. So if you got any questions, links, etc., throw them into the chat so that we can all see them and that they get captured. And let's see, merch stuff. I should probably order something sometime, but I've got so much stuff around already. But it's like some of this is cool. I love this little white SRS mug with the yellow logo on it there. You know, that logo has been in part of the club um, badge for, I don't know, 50 years, 40, 50 years, something like that. That'd be cool. It'd be cool to have one of those. But anyway, if you want any kind of merch, I know there's not a ton of different graphics in there. Um, I suppose you could, if you have ideas or suggestions of things that we might add in there. I mean, we have to be somewhat careful about the kinds of things we put because we have to have ownership of the images that we put in there, and everything that is in there is ours. So, um, but there's not a lot of different things, but uh, possibly past T-shirt designs, things like that. Although I think a lot of them would have to be modified probably to remove the year and date of the event, so that you just get the graphics. But anyway, that's a discussion for another time. But if you have some suggestions or ideas around that, just feel free to throw them at the Seattle Robotics Society email. Let's see. Do we have anybody from the Robothon committee here this morning? I'm not seeing anybody, so I guess I will step up to the plate because I usually attend these meetings anyway. Well, let's see. Well, Doug was there too. I don't know. Doug, you want to share about the upcoming Robothon?
Oh gosh, do I remember anything? There's
Well, I've
there.
got a slide there, so you can use that for a. Oh, and I also have a contest, a tentative contest schedule, so I can throw that up there if you'd like.
Okay,
But
that sounds good.
why don't
Um,
you just go ahead and talk through it?
let's see. Well, okay, so if August 22 is right, I could look it up on my
It
schedule to see if
it,
that's
it
right.
is, yeah.
Okay, and the punk rock flea market. It used to be, I believe, a Safeway, and it's on in the middle of Capitol Hill. Uh,
Mm-hmm.
which people have been calling downtown Seattle, but that's not what I would call downtown. It's up on the hill.
Mm-hmm. Mm-hmm.
Uh, and let's see, it should be. I haven't been there, since it's been uh, cleared out from being a grocery store. But having been a grocery store, it should be a pretty large area to
Yeah.
do our stuff, and should have a nice floor.
Yep.
So we'll see. Um, so all our usual stuff here, all our indoor stuff. So we're not
Mm-hmm.
doing the Magellan. I don't know if there's any
Right.
place even outside the building to do that.
Nope.
And let's see. Oh, so War is going to be there, and that means they're going to have their battle box and be doing
Mm-hmm.
their small battle bot robots.
Yeah, I think I'm trying to think if these are maybe 1 kilogram, or I don't know if they're
I think there might be even smaller than that.
might even
I
be smaller.
say
Yeah.
ant weight. That's my guess.
Okay. Yeah.
Yeah. So though, yeah, the ant weights, boy, ant weights. If you did what ant weights do at 1 kilogram, you would be I don't know what you'd use for a battle box.
Hmm. Okay. Here, let me roll ahead. So here's the tentative schedule.
Okay. And so I don't know if we're going to do anything for lunch other than let people go out and get lunch or have
Right.
lunch.
Yeah, there's no food vendors on site. I think there are some places kind of around the area, but not a ton of stuff. So
Unless they moved away, there's like stuff across the street and
mhm,
yeah,
yeah.
3 kilometers.
And then there's going to be a kind of a presentation talk about 3 kilogram sumo, and then first Washington during the kind of the lunch period in the middle there,
Uh-huh.
the noon to 1 slot.
So let's see. Build challenge 1, I believe, is that the one where you try and move in a square?
I think so. Yeah. There's
Yeah,
one,
it's
one of
15-foot squares.
there we go. Okay.
Oh, we've got yes.
Chaz.
You know more about this. Let's see. What's Build challenge 2? That's a long straight, isn't it?
Yeah, it was 150 foot, but it's kind of adjustable based on the place we're doing it. Yeah.
Yeah, I don't know if we can fit 150. Well, we'll see.
Yeah. We'll just go out to the main road and
Yeah.
No.
Out the
I
door,
think-
down the street, around the corner, and back in. So
yeah.
No, we
Yeah.
can cut it back to 50 feet.
Yeah, we can.
And we've done that, I think, before.
yeah. Okay. And then the pop can challenge. That's a fairly good sized area for that one. But then I don't know where that's going to be set up there. But I think and then Chaz, maybe you can correct me if I'm wrong here, but I think the plan is to try to set most of these contests up, the places where they're going to run ahead of time.
Yeah, or at least first thing in the morning.
Yeah.
War gets in there pretty early to finish up their stuff, so I think we can get in as early as we can.
We're going to talk about that at the next meeting. I think it's next week
Hmm.
or the week after. So
Okay.
Don't worry, I won't eat your stuff.
You can eat my stuff if you want it. I just didn't want to be in the way.
Thank you, like her.
oh, no problem.
Box up.
Sorry.
I'll do what I can.
We can mute.
Okay. Let's see. Does anybody have any questions? Anybody else online that's got questions? We actually have a good chunk of the Robothon committee here now.
Yeah.
Okay. If not, I will go ahead and move along to the next one. Oh, and yeah, all the stuff, like how many robots that are signed up for contests and stuff are on the Robothon page. So just hit that to kind of see what people have signed up for. Resources page, I've mentioned these before. Maker spaces, and
Did you actually show the robothon.org website?
I didn't. You want to see it?
Just the URL is what I meant.
Oh, okay. Let me see here. Oops.
Yeah, there it is. Oh no, it isn't. Let's see.
No, I'm sorry.
Get that in there somewhere.
There it is. Okay, over here on the lower right.
Yeah, robothon.org. Well, it's probably
Robothon.org. Or you can, if you got your phone handy, just scan that QR code and it'll pop up. So yeah, so that'll give you everything, the contest rules, all the technical stuff that you would need to actually put together something for the contest. Let's see. Actually, now that I see that Donna is online, and so I have a simple question. Hi, is there going to be Arduino meetup group here later this month?
I really wasn't planning on it.
Okay.
And the main reason being is that with next month being the Robothon event itself, I'm real time strapped going to that. And then
Okay.
also, the last meeting for that group that we had, there were only like 2 people that showed up.
Okay.
And so, interest, at least this time of the year,
Yeah.
seems to be dwindling. And,
Okay.
if I balance the ROI on this, it doesn't, I decided that for, at least for the short term, until after we're through with August. So
Okay.
what my plan is to restart that again in September.
September. Okay.
Okay.
Yeah, I had a slide for it. I couldn't find anything on Meetup about a current meeting, so
Right. And that's the reason.
Okay.
In fact, I'll make myself a note here, Steve, that I'll send out a meetup wide announcement about that, about taking the rest of the summer off.
Sure.
Going back in on September for that.
Okay. Thank you, Donna.
And I'm sorry to interrupt, but
Yeah,
back
go
to
ahead.
that idea of the information for the Robothon event itself.
Yeah.
So there are 2 different pages off robothon.org that are relevant for the event. One of which is the registration form and basics of for pointing for all the different contests that are available. The pointing links off to the various rule sets. Then there's a second page that's available too that details for the information about each contest and what the plan is for that. So just as an FYI, that there's 2 different pages available off of the homepage for the event. Okay.
Okay. So that's yeah. I was just going to run over there really quick here. So let's see. I'm going to go back to. Oops. All right. So. All right. So we got the home page up. So let's see. So we've got. And there's also there is also a meetup announcement for the event as well. So okay, are you talking, Donna? These the registration agenda page and then the venue and the events.
Yeah.
detail?
Right. Yes. Yeah.
Two,
I don't remember
there.
what the various pages were called, but yeah, there's registration and then there's venue. Yeah. Registration is separate from venue details.
Okay. So yeah. So that. All right. And there's those people that are signed up for the contest, and so. Yeah. So anyway, should be, it's probably getting close to, other than possibly new additions here, as if there's other people that sign up for the contest. This is pretty much the way it's going to be. I am going to be in Seattle over that weekend, so so any of you guys that'll be there in person, I will get to see you for first time in how long?
Years?
Be
a few years now since I was over there. Yeah.
Steve, as long as you're there, scroll up a little bit.
Up to the.
No, the other way down, I guess.
Down. Okay. What are you looking for?
I just noticed that we've got line following no loop counting and line following loop counting. So if you've got a really simple line following robot that just keeps going forever, you can enter in the no loop counting. Or if you've got a fancy line follower that can actually see the start finish line and count how many times it's crossed it, then you can enter in the line following loop counting.
Interesting. Okay. So that's good to know.
And of course, you can enter in both.
Yeah, sure. Okay.
We had quite a few line following entries, I believe, last time. Donna, do you remember?
Yeah. I remember let's see, I think it was last year or the year before when we had a Robothon event day at the field house.
Yes.
We had a huge number of line followers that day. And they were people that had never been involved in the in the activities before. And I haven't, frankly, they seem to disappear. I haven't seen them since.
Oh,
Here it is.
So that was the biggest, at least in recent memory, the biggest time that we had line follower participation.
Interesting.
Hey, Donna, do we actually have no registration for line following, or it's just not up yet?
Let's see. So
Did you want? Oh, you
line
want? Here.
yeah, line following. Line following. We do not have anybody up yet for that. I mean,
Yeah.
you know, perhaps that's going to change.
Yeah,
I would
Yeah.
really rather not take that off. I mean, this is just my own idea. I'd really rather not take that off the
Let's not take it
available
off
list.
yet.
Yeah.
Yeah.
I know,
No.
but exactly, because I mean that's at number one. That's a big hassle to set up the course, okay,
Mhm.
and all that. I myself can compete, with
Okay.
with that, but if I'm the lone wolf,
Yeah.
it doesn't.
Greg's gonna sign up for that too. He
He is? Okay,
Yeah,
well,
he told
okay.
me on Friday he was gonna.
As long as we got people, I don't
Perfect.
care. I just want to make sure we're not.
I know, but yeah, you're right. Line following is the absent
Mhm.
one right now.
That being said, if you think you're gonna attend, maybe just sign up now
Yeah.
instead of the last minute.
Please.
Yeah,
Please. It's okay if you show up with a robot that doesn't work. That happens to me every year.
right. Yeah, so that's an FYI for everyone who's on the call today,
Yeah.
is that if you do plan on at any level, even if your plans are just tentative right now to actually have a robot ready, please go through the effort and do the registration. Then that way it's better if we're over planning and people can't show up for that reason versus that people come at the last minute and want to compete and and it's unplanned. So please follow that guidance to pre-register.
Yeah. Okay. With that, I'll go ahead and throw this back up there. And I don't think I don't recall seeing Bob Cook on the call this morning, but he's one of the hosts for the Vancouver robotics meeting, and this just kind of popped into, and I don't know if I think I got an email notification or something like that about their upcoming meeting, or no, I'm sorry, I stumbled onto it in the meetup because he mentioned, I think he talked last month about he's looking into some alternative to meetup because it's that gets kind of expensive because it's a what is it, $170, $180 per 6 months now, so they're getting to be quite pricey. But anyway, there's just a couple of groups that these are, I think they're both virtual. So I know DPRG meets weekly. They meet every Tuesday evening. They have a 2-hour or so session, and I've got other things going on Tuesday evening, so I have not been able to join in on them. But I would love to do that sometime. But if anybody else happens to plug in there, just give us a little feedback on what these guys are doing and what do you think about them. And then I should have added 7:30 is probably Central Time, so that's I forgot to put that on the end of there because they're in Dallas, of course. Vancouver is, of course, Puget Sound, so it's they're on Pacific Time. So anyway, just some things. The website, the Vancouver's website is relatively simple. They rely, I think, mostly right now on Meetup for the specific details of what their meetings are going to be. So anyway, and there's lots of others. I actually have a page on the SRS website which links to a lot of these online clubs as well. So there's many places that you can plug into pretty much on a regular basis if you want to via Zoom. Let's see, presentations, and I don't see I'm trying to remember. I don't remember exactly his name. He was supposed to reach out to me with some contact details, because I would love to. I'd love to put somebody in the slot next month, which will be a week before Robothon. So I currently do not have a presenter for next month. But if anybody knows somebody or is interested in sliding into that slot, I will try to fill it between now and then, but no guarantees. So we can handle just about anything nowadays, thanks to Zoom. So I'm happy to accommodate any reasonable place on the planet, for that matter. And then, of course, there's obviously also opportunities to share about your projects, and perhaps maybe we'll get some interest on some of the robots that compete in Robothon, or if you wanted to show something, I would love to see a few of the robots that are going to be competing in Robothon, possibly at next month's meeting, if you're okay with sharing that. So keep that in mind. We'll see what kind of works out. You know, we seems like we could just sit and talk about robots, and we can have just as good of a time even without a formal presentation. But I like to try to throw something in there as much as I can. Okay. And open topic discussions that I mentioned. Some you can pick something, and we can do a facilitated discussion, talk about videos and things like that on subjects. You don't have to be an expert on the topic to lead the discussion, because it's not really about your knowledge about it. It's just kind of throwing it out there, and we just kind of banter around about it, and it's usually always fun. Those kinds of discussions can oftentimes touch on things that nobody planned on, so it's always cool. So we do have a September presenter, and we've got the first team. Crash Out is going to be sharing with us here a little bit later this morning, and let me see here. Let's see who here online is representing them. Could you unmute and just identify yourself for me, if you're there? Okay, I don't see anybody jumping out yet, so it's possible I will touch. Actually, I'll just touch them here briefly in a bit. So anyway, got lots of open slots through the balance of the year, and then of course we've got Robothon is right here in between August 15th and the 19th there at the 22nd. So let's see, for just general review, everything here, you guys all know almost all of this stuff here. So we've been putting stuff on YouTube since May 2021 now. So we're going on, what's that, 21 to 26, 5 years. We've got 5 years plus worth of online meetings now. So that's really cool. And I'm one of the things that I've been doing for is going back and kind of hitting on some of the presenters who presented before we were recording, so that if it's possible, we can get their presentations onto a video recording so that they can be available for the future. So okay, so we are to the part where you guys get to share, and I'm hopeful that some of you guys have got some things to share. I've got a few things here that I can kind of start out with, but would love to hear from you first. So why don't you, if anybody's got something they want to show us or share with us, please do. And don't all volunteer at once here now. Come on. Surely somebody's got something.
Nobody?
Nobody. You got anything, Blake?
Yes,
You?
my slight pain in the rear rover I've been working on. Other than
Okay.
that,
Yeah, go ahead and show it.
so this was the kit by Circuit Mess. And after doing some more research onto it, I've discovered there was a short on the internal of the motherboard. So
Oh,
let's see if I can. Dog, go lie down. Like, go. Let's see if I can turn off the background
okay.
section because I'm not sure if it.
Here we go.
So
Okay.
this,
Whoop. Yeah. You better turn your background off. It's doing really
I can figure out
wonky
how to
things.
do it.
The little side arrow on video, the little up arrow on the video down on the bottom there. You just hit the
Yeah,
up
it
arrow.
didn't give me the option for turning that section off. There we go.
Oh, yeah. There.
Have to
Okay. There you
have to
are.
manually do it this time. Okay.
Uh,
So this one is powered with four small electric motors that go to the front wheels and the rear. So far, when you turn it on, the speaker works. One of the issues I am having is only one of the LEDs turns on. Supposed to have forward red ones, a couple forward facing white ones, and a couple green ones in the rear.
mhm.
And unfortunately, I don't think you can hear it over the laptop, but my servos are humming. So usually when you've turned on a robot, the servos will find their zero. These ones haven't done that yet. So this one is supposed to come with an out-of-the-box set of program. Apparently, there's something that's a little bit corrupted on that one. So working with CircuitMess to find out what's going on with it. Haven't heard from them for a couple days, which I'm not too worried about it because daily I would like to put an Arduino or Raspberry Pi with this one
Mhm.
and have it do a lot more than bare basic Python programming with the,
Okay.
I forget which version this one had. But yeah, that's lately what I've been working on. Just doing some R&D. So everything's getting the proper voltage. Everything's supposed to be receiving signal. It just doesn't for some weird reason. That's about all that I've
Hmm.
got.
Hmm. Curious.
It's been a lot of fun though. I love this thing.
Yeah. Anybody have any questions for Blake about that? All right. Let's see here. Okay. All right. Let's see here. I am. Okay. I'm still. I'm gonna go ahead and pull it back up here. Let's see. I'm just gonna send a quick tickler here to. Um, yeah. Okay. Sorry about that. A little things tend to run a little bit more slowly in the background here. All right. Here. Here. All right. So, nobody else got anything to jump into? Because if not, I will go ahead and throw out a couple of things that I have. Okay. Um, so this was this battle kits was kind of an interesting thing. I actually got an email from a guy who works for this company who builds these kind of like base platforms for combat type robots, and they've got, you see, they got the three different weight classes on these things, and I'll just they were inspired by the apparently a particular competitor, Biohazard, and the company itself does motors. Kind of their specialty is motors, and on the resources page, there's a link to this really cool calculator that allows you to sort of plug in different parameters, and then it will figure out what's the best motor for your application. And so part of what they like to do is get into this kind of stuff. And let's see here. So if I go, let's see, versatility. So they're fairly, chain drive. I'm not sure, is that that's two-wheel, it's got drive on both ends of the track. Not certain about that. No, oh no, okay, I see it. The looks like in the middle. Okay, so you got your drive motor. Yeah, okay, left and right drive motors in the middle, driving through a chain drive system then to drive the front and the rear wheels. Of course, in combat robots, the biggest challenge is building something that actually survives the onslaught of your competitors, because if you've ever watched how those things, the kind of weapons that people put on those things, they can get pretty vicious. And so it looks like, so this one bear weight is 21 pounds, and looks like with motors, batteries, and amp flow controller is 37 pounds for this particular class. And then you go up a level, you get up to let's see, this one's about double, 62 pounds for this mid-class one. And it looks like they've split the drive now so that you've got four-wheel drive on this thing. So there's actually 4 motors in here. And so bear weight is still, well, it was 21 pounds on the other one. Now they're up to 31 pounds for the bear weight, but then you're 62 pounds by the time you load this thing up with all of the other hardware. And you haven't put anything on top of this yet. So this is just the bare base drive chassis. Chassis, batteries, controller, motors, with none of the rest of the stuff that you might put on there. And then take it up yet to the heavyweight class. And as you can see, it's getting to be fairly big now. It's 30 inches long, 24 inches wide. So it's getting to be pretty big. And you've gone from, let's see, I think the middle one here, you've gone from a single controller in the center and the back now. So this one actually has two independent controllers, which could be advantageous if you're concerned about redundancy. And then it looks like you've got 4 batteries, so 2 in the front, 2 in the rear. And you're up to 83 pounds for the basic chassis weight with this guy.
So it looks like they're starting with square channel, and they cut slots in it to make each of the ends. But how are they joined to the center? I can't see any sort of. They might. Well, I don't know how they're doing it. You can't see any angle iron, as it were, or how are they joining those left and right to the central plate? It looks like they've cut slots in that back plate there, so that the straps from the batteries can go through the slot.
Yeah.
But that means that a competitor could loosen the battery if they cut the strap, but that'd have to be a very specific weapon.
Oh yeah, yeah, yeah. Because on the base one, everything is inside. There's nothing exposed. And I'm wondering if it's it looks like that kind of looks like just welds on the corners, but.
Oh. Are those welds? Okay, I can't see them.
Yeah, barely. It's hard for even on my screen. It's hard to tell.
Is that is that made of aluminum? What does it say it's made of? I
believe. Let's see. Yes, aluminum bulkheads and base plate. So yeah,
you can actually weld aluminum, or at least
yeah, right. But it would seem like you'd want that thing. You'd want it welded everywhere where you've got 2 plates coming together. I mean, you don't want to just be doing spot welding, because
right.
if you're I mean, you got to think, okay, I'm building a tank here. Okay, so
Right.
make this thing as robust as possible physically, because and then some of the competitions have the floor hazards too, where things come shooting up out of the floor to and you wouldn't want something coming up from underneath and breaking your frame. So
Now you can see the jack shafts. They go through the plate. They're one just in front of the back wheel on either side, and there's some sort of a keeper there on the end of that jack shaft, but I can't see what it is. It could be a cotter pin.
yeah, let's see.
They
Yeah,
They show 3 jack shafts. What are we doing with all that? Oh, because this only has one motor, so they have to um, chain from the motor to each jack shaft, and then there's maybe that third one, the back one, is not a jack shaft. Maybe it's something else. Although it's, yeah, I don't know.
I'm
See,
trying to. I don't know if actually the picture's not.
They're really, really proud of these things. Like as shown in that configuration, that's a $1,700 robot.
whoa.
Wow. Yeah. These are they're not cheap. Yeah.
They're not giving them one.
And it looks like there's more than just a shaft there, just above the left motor there. There's something thick there, like I don't know what that is. Um, because a regular jack shaft would just be, unless it might be the way that the sprockets um, screw down to the shaft or something like that. But it's just like that's thicker than a
Yeah.
shaft there.
Hmm.
Yeah, that must just be the collet that the sprocket is mounted to.
Hmm. Let's see if I got there we go.
Steve, will you buy one and tell us how awesome it is?
Yeah.
I'm gonna see in person.
Uh, hmm. Yeah. Well, they look like
I wonder if
yeah,
these
go
have
ahead.
any relation to the old Tamiya track bot kits.
Boy, they could have been inspired by that, I suppose, but those were usually pretty inexpensive. I remember there was like plastic tracks and rubber tracks themselves and plastic motors or plastic gears and spools and things like that. But
So the base plate is drilled and countersunk with 84 holes.
84, huh?
Oh, for 3 sizes of batteries. I see. So they have all the stuff you need for whatever you want to put in there.
Yeah, yeah. They're trying to make a kind of a somewhat generic platform. I mean, it has a main intention, but they're trying to give you flexibility in terms of how you implement that. And
I would
you don't.
say that one of the things you'd want to be able to have a selection of would be wheels, but they don't have the clearance to have other kind of wheels in there.
Yeah, and these look like those look like rubber tires to me, and rubber tires can get torn to shreds in combat robotics. Seen it happen. So, and if that happens, how much mobility does that thing still have?
Well, if you get this version that has 4 separate motors, you have separate ability to drive each motor. So
Yeah,
if you have your controller set up for that.
yeah, yeah, yeah. It's kind of interesting. So the one here, the heavyweight one, looks like I'd almost kind of wonder, and I don't know what you guys would think about that, but it would kind of make me wonder if I'm looking at the wiring on that one. I'm trying to decide if the wiring crosses diagonally. Like they're using the left controller, but giving you ability to control one motor on each side of the robot. So if you lost one of them, if you lost one side, you lost one of the ability to control one side, you'd still have the ability to drive both sides of the robot, so you could control it at least to some degree.
When I saw that picture, I thought that those wires were actually not connected up, but they did at one point say that everything would be connected up. Maybe they're not connected up in the picture. It looks to me like those are just the wires that come with that motor controller, and they're just tucked in there. They're not
not actually hooked to anything. Yeah, is this an actual functional system?
I don't see any wires to the batteries or even to the motors. That looks like the wires for the motors are just kind of wound around the motor and left there.
I think you're right. I think you're right.
That's connected up.
This may just be a mock-up that they did to get a picture of the mechanics out there.
Yeah,
you know,
I think you're right.
It can be difficult to market this stuff, and sometimes you just throw together what you can in order to get a picture out. I think also a lot of times, like, especially with us technical nerds, we have a tendency to forget about like marketing.
Yeah.
So I've seen a lot of really bad photos, and like some of them are bad photos on really bad products, and some of them are bad photos on really good products. It's hard to know.
Well,
I like their frame, like you guys were saying.
Yeah. Well, you may recall, Dilbert didn't have a particularly high regard for marketing, the marketing department of his company. So. but I mean, you got to be, yeah. See, we're already thinking about, okay, if we were going to build one of these and put it in a competition, what kinds of things would you need to be thinking about? And one of them is redundancy. Absolutely, to be able to, because you're going to lose systems. It's inevitable. I mean, you can't make one of these machines and expect that everything is going to work perfectly until you beat your competitor. I mean, it's right. Chances are you're going to take some damage, and you need to have some ability to, be able to survive that and then still be able to function. Because how many people have ever watched some of these videos where the competitor starts slamming on a robot and taking out systems, and pretty soon they're immobilized. They can't move anymore. And once you're immobilized, you're done, because if the other guy can still move, he's going to go around you and he's just going to take you out as much as he can. So you need the ability to move and be able to survive those kinds of hits.
Notice in this picture, just to the left of the sprocket for the lower left motor there, you can see a hole in the outside. So that's how they got in there to work on it, I guess. But
yeah,
you'd want a cover plate or something if you're going to be a battle bot.
Yeah. Well, yeah. I remember when we were doing we've done a number of co-events with the WAR, Western Allied Robotics Group. But I know I seem to recall hearing one of them kind of talking a little bit about how they make their robots. They make their robots fairly simple, but they're very repairable. I mean, they can repair them with duct tape and baling wire. I mean, they're built. They're not particularly sturdy per se, but they
don't have the weight limit, right? Because of the weight limit, they can't make them strong.
Yeah. So they can. It's like when they take damage, it's relatively easy to replace major parts. I mean, they can, if the motor mount breaks on a drive motor, they can usually just cobble in a replacement for that, and get back in the, they skip a round or a bout or two, and then they're ready to go back in again. And so it's, they're built to be easily repaired. I guess that's the main thing.
Because they expect to get trashed.
Yeah. It's an assumption. And I was thinking, this brings to mind that, let's see, was that I think it was in the first Batman movie. Do you remember when the Batmobile got, I didn't even remember how it happened there, but the Joker did something there where the Batmobile was just utterly trashed and mangled, and then Batman does some things where the thing sits there and it essentially ejects the bat cycle. It sort of puts itself back together again in this really simple, basic configuration, and the bat cycle comes tearing out of the wreckage of this thing, and it was like it was just funny, It's just like, okay, yeah, sure. Yeah.
I was imagine if you did lose a wheel on this one, if you could like send a code and it would eject the wheel and just drag on that edge. But that would probably be too much equipment even to try and make such a thing possible.
Well, it seems like rubber tires a lot of times on the competitions that I've watched, there's usually lots of shredded rubber in the arena. I mean, they have to usually send somebody in there with a broom and a dustpan to clean up all of the stuff that the robots shed, to try to make it so they can get around in there. And it would kind of seem like, I mean, I realize if you have metal wheels are not going to have great traction.
Right.
So you need something that has some traction to be able to push and move around on a hard surface, because that's what you have. It's usually, but then at the same time, you want something that, like if these tires got shredded, how much clearance does the wheel underneath have below the frame? I mean, could the thing still actually make contact with the floor underneath the frame, or is that wheel going to become worthless even if the drive system still works?
And I'm wondering why they have them sticking out the end. You had that within a metal cover. The advantage is it protects the wheel. The disadvantage is you could get high-sided, right?
Yeah.
Get tipped up onto something and not have any drive at all, and you don't want that.
Yeah.
So it's a lot of stuff to think about.
Yeah. And it'd be interesting to see what a finished version of this thing might look like, where, what would somebody put? Because I would assume somebody's going to put some kind of a protective shell over the top of this thing. And it's going to be, and I don't know that, I don't know what kind of size restrictions that they have. I mean, obviously, if it's, they have to be able to fit inside the arena, and there must be some limitations to how big the robots can be. But at the same time, you can build a kind of an armored shell that completely covers this thing as much as is practical. Oops. Okay. Well, that was interesting. Okay, so let me go back to this one, and I don't know. This is a little short 2-minute YouTube video on this. This, it's called Neo's Hands. It's a robotic hand. It's actually pretty cool. Let me see if I can.
Wow.
Okay, just a sec here. I am going to, let me try to expand this so you can kind of see what's. Come on. Okay. Let me see if I can get this to. Yeah. Doesn't look great, but okay. Oh. Are you guys, let's see here. I think I need to stop sharing for a second. I have to switch they got this orchestral symphonic background. So let me see if I can get to that. All right. Let's see here. Okay. So so this has been around for a while, James?
More that the idea has been around in my head
Yeah.
for forever. It's one of those things that I just think is self-evident and the only way to go, and like literally nobody else in the world sees any value in it, which is fine. So I just keep doing it for myself. And just recently I kind of hit on a better way of managing it that allows it to control more different devices. It gets past some of the limitations of the original idea. That so just to very quickly explain it, the whole thing in my mind is if you can compress a language down to the point where every single keyword is a single character, okay? So think about this, like what if the if keyword were just the question mark, right? I mean, question mark is basically if, right? What if the assignment operator were a colon, and the return, instead of return, you use period, right? So you can find like single character operators for almost everything, and then you limit yourself to 26 single character variables, right? This is like going back to the olden days of like, I don't know, mouse and squeak and like, silly little languages like that, where all your like the very first versions of BASIC, right? Where you
Yeah.
only had 26 variables and they were the letters. And then, there's a pattern, which is kind of destination is assigned the value of operation on source. And then you can repeat operation source, operation source, operation source. So you can have something like A colon B plus 2, right? And so you can see every one of those as a single character. So the point of that then is that you don't need like a compiler. You don't need like an interpreter other than just it's a bytecode interpreter. So you're literally interpreting bytecodes that just happen to be human readable and happen to sort of look like a language. Now, for use with devices, just as an example, you would type in this has been working for a long time. you would, like, say you wanted to turn on the LED on an Arduino, right? You would just type in 13H, and the H, uppercase H, not lowercase. Lowercase is the variables, uppercase are the commands. And so H stands for high. And so that takes pin 13, sets it as an output, turns it on, right? If you want to turn the LED off, that's 13L, right? If you want to know the value of pin 13, you can do 13I. And then the more recent developments is I've come up with a way of doing devices which uses a call syntax. So there's always been this thing of opening parentheses and closing parentheses. Opening parentheses start building a parameter list, and things that are specified after that get pushed to the stack. So what I did is now you can use that with the D letter. So uppercase D, open parentheses, quote, for example, R for an RC servo, ending quote, comma, and then the pin number, and then a closing parentheses. And that collects all those parameters up and sends it to D, and it returns, the return value is an RC servo driver. So like you could say, you know, lowercase R colon D open parentheses, quote, uppercase R, quote, comma, 5, close parentheses, enter. And that makes the lowercase r, that register, now holds a device definition for an RC servo. So now you can say things like R colon 90, and the servo will go to 90 degrees, or R colon 45, and it'll go to 45 degrees, right? Or you can set up A as a 0, and then you can do a loop with square brackets where you take A and push it out to R, which moves the servo to that location, and then you can increment A, and then when A gets past a certain point, you can, you know, switch the sign on another variable and make it go back and forth. So you can like build up these little things, right? You can build a thermostat, right? So you could like read an analog pin that's hooked up to a temperature sensor, or you can assign an I squared C device now. I haven't actually tested that, but you should be able to read like a temperature humidity sensor and then get the values out of it, and then have a loop that checks that value and says, you know, if it's lower than the set point, turn on the heat, and if it's higher than the set point, turn off the heat, you know, and that sort of thing. Or you could, what I'm using it for, my first use case is I have a little Raspberry Pi type device. It's actually a Jetson, but it turns out that SD cards do not like to have power fails, and they don't like to be, you know, like just like unplugged unceremoniously. So if the power happens to go out, I have a battery hooked up to it, and I'm going to use this little device to monitor the battery voltage through a resistor divider. And when it gets below a certain point, it'll send a signal to the Jetson telling it to safely shut down, right? So that's pretty much implemented and working, but it's just a simple example. This all comes from this realization that like every single time I'm working with something that has an operating system on it, you can't really do good peripheral I/O with those things. They have all kinds of timing issues and garbage collect pauses and all kinds of stuff like that. And you need some little bare metal device. And so you're always writing these little, oh, well, I'll program an Arduino to do this for me, right? And take a command from the main device and then, you know, do this one thing. And you write those over and over and over and over, and you start to see that it's always the same damn thing, right? So I was just like, okay, I'm going to write something that allows me to both A, not have to keep rewriting this. I can write it once and then just keep reusing it without having to change it. And then B, be able to debug what's going on because I'll be able to talk to it with human readable codes instead of like binary codes. So I don't know if you've ever heard of Fermata, but it's kind of like Fermata, except it's human readable. And it just seems brilliant to me, but okay, I've rambled on long enough. Onwards and upwards. Thank you for your patient attention.
Oh, is that like math? I was just looking up your reference to Fermata there. So that references a guy named Adam Furman. Fermata musical symbol. Oh my goodness, wow, that's a looks like a real rabbit hole there. Can dig it down, flying down that one.
Well,
Yeah.
yeah, Fermata is in general a symbol that relates to music, but there was a well, I think it was originally related to JavaScript, but basically it was the same sort of thing that I was just talking about, except it uses binary codes.
Yeah.
So you have to have a binary driver on the host side,
Mm-hmm.
like on whatever you're using that has an operating system. You install their library, and then it sends these binary commands to whatever device you've programmed.
Mm-hmm.
But you don't have to like reprogram the device. You just download their, program and you put it in and away you go.
Yeah.
But the issue is that you then have to have whatever language you're working in or whatever you're doing, you have to have a Fermata driver on the OS side. And what I'm
Mm-hmm.
saying is, we'll just use human readable strings. Just send a string to it,
Yeah.
right? And then you can
Yeah.
talk to it and it works.
Hmm.
Anywho,
Cool.
too much time spent on that.
Any other parting volleys? Because if not, we'll jump back to this. Whoops. Okay, I'm not absolutely certain about my presenter today. Again, is there somebody from First Team Crash Out on here at this time?
Yeah, we're here.
Okay, cool.
Yeah.
Cool. Okay. Yeah, I was checking earlier and let's see who let me find your how do you say your can you pronounce your name for me?
Soham.
Okay. All right.
Oh, it's
So
so hum like so and then hum, or do you kind of run them together like so hum?
Yeah, like sort of together. It's like Soham works. Like, yeah.
okay.
Oh,
Okay.
cool.
Okay.
Thank
Yeah.
you.
So I'm seeing you're showing up right next to me on my view here. So okay. Good. Good. So let's see. What are we getting? We're actually getting really close. I'd like to just take a brief break here. I'm gonna run to the restroom and grab a refresh on my beverage and and then we'll get you turn you guys loose to share what you got.
Okay, yeah,
So
sure.
yeah. So I've got so it's probably about 11:04 your time. So let's make it about 11:10. We will reconvene.
All right, sure.
Okay.
Sounds good.
Okay. Thank you. All right. So let's see here. I'm going to go ahead and stop sharing that. Okay, so we've got members of the first team Crash Out, and I'm going to let you guys just go ahead and take the reins and share with us whatever you got.
Can you see my screen?
We sure can.
Yeah, you can. I think we're all going to start off with introductions, just introducing us. I can go first. My name is Raghav. This is my second year around doing FTC robotics, and I'm mainly a cadder and builder.
Yeah, my name's Soham. I've been doing FTC for 3 years now, but I've been doing first robotics for 4. I'm lead programmer on FTC 23405.
My name is Sai, and I've been on FTC for 3 years, and I am lead cadder, and I help build.
Yeah, so we're going to be presenting about FTC robotics like in general, and then after the presentation, we can like go more in depth about what we did last season through like our engineering portfolio.
Yeah, and if you guys have like any questions throughout the presentation, like any words you don't understand or concepts, you can just ask us and we'll answer.
Yeah.
But yeah, without further ado, we can just get right into it.
Just one quick thing, just for everybody online. If you do have questions or any kind of thing, feel free to use the chat. That's because that will actually get captured in our notes.
That'll work for us too.
Okay, take it away.
Okay.
So this is just a presentation about FTC robotics. So what is FTC robotics? Well, FTC robotics is just a competition hosted by FIRST, and FIRST is an organization which hosts different robotic competitions. FTC is one of them. There's also FRC and FLL and other stuff. So in the FTC, there's a couple of skills you need to learn to even participate and do well in the competition. There's 2 sections to FTC, I would say, technical and non-technical. So first, our technical skills includes like computer-aided design or CAD, and this is like creating your robot online before actually building the pieces. This is very beneficial because not only in FTC, we make our own parts instead of just buying them using a 3D printer, but we also like to plan our robot ahead to see if anything goes wrong in any of our designs, and that's what computer-aided design is for. And then programming and hardware is a little bit obvious. We use programming and hardware just building our robot in general. There's also an autonomous section in FTC in our competition. So we get 2 minutes and 30 seconds to perform our robot with another team. And the first 30 seconds is purely autonomous, which means all our robot does is just run on the code we made beforehand. And then for non-technical skills, FTC also includes fundraising, marketing, community outreach, and obviously teamwork. These are all really important to do well in the competition. And the judges also look on how our team has made an impact on our community, both just in our state, but also internationally. We can also make impacts. And we document all these things in our engineering portfolio, which we will show after the presentation. And then our robot has like certain like requirements we have to fill. It must be in the 18 by 18 by 18 cube. And then our code should be in Java. And then, like I said before, the first 30 seconds. And then there's a field that's given every year. There's a new challenge with the new like field components. But our general field base is a 12-foot square field, which 2 randomly paired teams must work together as an alliance to defeat the opposing team. So 2 teams against 2 teams will be on the same field. So 4 robots in total. And it's just competing on who can get the most amount of points. And then teams score points by performing like specific tasks depending on the game. This year, the game release hasn't been released yet. But last year, we had to throw like wiffle balls almost into like a basket, kind of like basketball. And then Like I said before, our teams must show our team impact in our engineering portfolio. And then who we are, well, we're just a dedicated team of high school students, and we really love STEM in general, so that's why we wanted to pursue this and do FIRST Robotics. And there's some core principles we uphold. These include gracious professionalism, and then we use engineering design process and different things to create our robot. And we also aim to grow our skills not just in robotics, but in other fields overall, like our work ethic and how we approach different problems. And that's also like one of our goals in FTC. But yeah. And then this is our process on how we actually build our robots. So we go through like a cycle almost, or like a process on how we build our robots. And this includes first defining what's the problem, what do we actually have to build a robot for. And then after that, we brainstorm possible solutions. So we would define like what this year's problem is, what we actually have to accomplish. And then we would brainstorm different robot ideas on like how we can approach this problem. And then we would CAD, like I said before, design online. Before actually building our robot, we would always design online on what these the different robot capabilities are, which one should we use. And then after that, we build and test our robot iteration, the robot we created, see if it's actually working how we want it to, what changes we have to make. And then number 5, finally iterate. We use the robot design that we made and just make tweaks, changes to make it like as good as possible. And then finally the cycle starts all over again, where we build a new robot as the season progresses. And there's also a software engineering process, but they're more or less the same.
All right, I got this slide. So this is about FTC CAD. So first, let me tell you what CAD is. It stands for Computer Aided Design, and it's an online modeling software that you can use. And it's very helpful because you can literally plan out all your subsystems just online without having to do it in person and maybe run into problems, which you most definitely will. And it all starts with identifying and analyzing. So first, you have to look at the FTC specific game, and you have to make sure it's 18-inch by 18-inch. And that's one of the first steps because you always want to define your constraints before making a CAD. And then next, you have priorities. So you have to determine which subsystems are going to be the most important and which you have to start. And you have to build around these subsystems. So it's really important that you determine their priorities. Next, we have the brainstorming and sketching. So as a team, we go on a whiteboard and we can sketch rough dimensions or make a sketch of an idea we have for the game. Let's say you have a specific claw that would work for intaking artifacts or game elements quickly. So brainstorming is really important. And we also have an Onshape master sketch, and this is software used for pretty much all of our CAD. And you can make rough dimensions on this CADing software, and it's a really good tool for just planning out your sketch and making sure you have a functioning drivetrain sketch, master sketch. And then we have the 3D model and assemble. So we use Onshape to design different subsystems, and we make sure that they're all going as planned, so they meet the constraints, they can meet the objectives, and we also can import parts on Onshape libraries online. And by importing these parts, we can make them as accurate as possible to the real world, and then we verify and fabricate. So first we look at virtual testing. We look around, see if there's any collision or rubbing parts that could be a problem, because obviously Onshape is a tool online and it's possible that there are parts that are ramming into each other or clipped into each other. And then after we verify that everything is good, we make it physical. And one rule that we have on our team is that we always have to CAD before making anything physical, and we have to test. And then usually after we're done CADing and we make it physical, we try and build it. And usually there's some problem because there's a lot of unforeseen problems, and we just iterate. And to our left, you see an example CAD of our drivetrain with an intake subsystem. And to the sides, you also see linear slides. So this is for FTC, common FTC mechanisms. So first, there's a drivetrain. And in this example, to go build a strafer chassis. And this moves the robot, and it's omnidirectional strafing, meaning it doesn't matter. It doesn't matter like if the heading of the robot can still move in different directions. And a drivetrain usually has a center of gravity that's towards the middle and low. So you can add components off of it and make your center of gravity stable so your robot doesn't topple during the competition. Next, we have an intake. An intake collects field elements, and it has active spinning rollers usually. That's called an active intake. And usually there are funnels at the end of the robot that make sure that the game elements can go into the roller wheels, and then it can go on the transfer, which is our next component. So the transfer elevates the scoring lift, and it's basically the place where the game elements get transferred from the intake to the shooter. And the transfer is a very important mechanism, and usually the last subsystem to be designed, because you need to have a finalized intake and shooter before you even start thinking about the transfer. And the transfer is very important because it transfers game elements, and it also is a place where you store game elements. So it's really important that you optimize it for storage, speed, and just its ability to transfer with a good rate, a good success rate. Next, you have a shooter. So this is our artifact prototype, the one you see, the chariot, and it launches game elements and usually has a very high speed flywheel. And this flywheel makes contact with a game element, usually from compression, and that allows the game element to fly very rapidly and go far distances. And we can also, with a lot of testing, we can make sure it lands in a certain trajectory to promote our success. And then next for the claw, which is the last thing. Not all robots need a claw, but it is an important element of FTC because a lot of robots use it. And it basically just grips the game elements, and it's usually servo powered, and it has high friction material to assure it has a good grip.
Yeah, so next is like the programming section of FTC. So a lot of teams in the past have used like the state machine to control all their mechanisms and subsystems, but like command-based programming in FTC has started to become more popular. So that's what we've been incorporating in our robot as well. So how it works is that like there's a hierarchy. So first, the lowest level is commands, and then subsystems are on top of that. Then we have like a robot class, which controls all the mechanisms, and then after that we have our teleop op mode or autonomous op mode, depending on what mode or what program you're in during game. But usually for this example, I took teleop op mode. So in the teleop op mode, you'll call your robot class, and then you can handle all your commands inside the teleop op mode. So over here I have a screenshot of our intake class. It just has a simple like set power command over here. And then after that, we take all of our mechanisms. So we have an intake, like a limelight camera, linear slides, a shooter, a turret sometimes. And then we put that into our robot class. So, we're calling instances of all of our mechanisms in our robot class. And then in the robot class, that's when we actually create commands that interact with all the mechanisms. So let's say that you want to intake a ball, but then you also want to transfer the ball immediately. Then you could have a command that sequentially calls like intake turn on and then transfer. And then after that, in the teleop mode, that's when you can bind all your commands onto like a controller to control the actual robot when you want to run a command. Yeah, there's plenty of other command bases that are in FTC, but so we use last season we used two core programming libraries. So we use Pedro pathing, which is for autonomous pathing, and then Next FTC, which is for structuring our code. And this example back here, actually, this is not from Next FTC. This is from a new command base called Pedro Ivy that was also released by Pedro Pathing. But last season, we did utilize Next FTC. So Pedro Pathing handles all of our autonomous robot pathing using Bezier curve-based trajectories. If you don't know what Bezier curve is, they're pretty easy to take derivatives of. So that's why they're nice, and they're also pretty easy to generate. Then there's also a built-in command base which lets us schedule and manage commands cleanly. That's the pager pathing IV command base that we're utilizing today and currently on our robot. And then it also has reactive vector-based correction. So we tune a bunch of PIDs for pager pathing, and then through that it's able to correct along its path. So even if it bumps into something along its path, it should be able to correct correctly. And for our sensors that we use odometry pods and like an IMU to get our heading. So we can get X, Y, and heading so we can know where our robot is on the field. And then Next FTC provides a clean framework for structuring code for FTC. It also simplifies all the subsystem management with reusable components. So you can just create a subsystem class, and then in that we can have all the commands for the subsystem. It also integrates pretty seamlessly with Pedro pathing, which is good because we want to be able to call all our commands during our autonomous routine as well, not just our teleop. Or teleop as in driver controlled. Yeah. Anyone have any more questions before we move on to the portfolio? Okay. I can share the portfolio now.
All right, well, this is our engineering portfolio. And yeah, this is an example of a cover page, and on the front page are our sponsors. All right, so about us. So again, we are Crash Out, team 23405, and we are basically just dedicated high schoolers who have a passion for STEM. And we started with 6 members, and then we recruited people on our team, and we got to 8 members last season. And we have 3 core principles really. Gracious professionalism, which is basically our day-to-day interactions with people on and off the game field, and it is basically just demonstrating kindness and understanding that at the end of the day we are all here for our love for STEM. So there's no like rudeness, and yeah. And then we also believe in failing fast. So this is basically because failing is inevitable in robotics in general, and probably a lot of other things too. And failing, if failing is really inevitable, we really want to make it better and iterate after failing. So that's why we want to try and experiment a lot. And this will help us improve as quickly as we can, especially with the timings we have for the competition. So next we have inspiring the next generation. So we inspire kids. We went to many elementary schools, and in fact, last season we went to India, which is an international outreach, and we helped a lot of kids. And there is a page about that later on. And we also connect with the industry really. So the whole category is just connecting with the community. So we connect with the industry part too, and we learn about innovations, and we gain a lot of knowledge. And then we also have mentors. They are Rachit and Varun. Rachit works at a robotics company and is actually having a job here at SpaceX. And Varun just is in UW. So our coaches have been vital in our development and growth as a team, and they share their experience because they've been in the STEM industry for a very long time, probably longer than we've been alive. So we really appreciate their insights, and their teachings are very valuable to us. And our team is always learning. We really value team growth, and there's always something you could learn. There's always more things to learn, and it's even better to implement them into our season. And we've been doing that because from 3 years ago to last season, I feel like we've strongly improved. Whether that comes to our skills in CAD or skills in programming, we have just gained a lot of knowledge, and that's one of the really important parts of FTC. It's not really focused on winning, but it's focused on what we take from it and how we grow as a team and as individuals who have different careers in STEM. All right, next for our goals. So we really have three categories of goals throughout the seasons. So for our community/outreach goals, we want to support new FTC teams, and we helped a team called Penguins in Disguise, and then we also helped a team called RHS Robotics. It's called Bot Not Found and Bot Got Found. Those are our sister teams, and Bot Got Found is actually a rookie team, so we helped them a lot during the season. We partner with businesses to secure sponsorships while spreading FIRST and the reach of FIRST to many different industries. And we also connect with real world professionals and gain their knowledge because they've been working in these fields for years. We track progress for these goals by collecting inputs, like doing surveys at the end of an event to see how many people would want to participate in FIRST and go into something related to STEM. And so far, we've seen a lot of involvement, or a lot of wanting to become a part of something related to STEM. Our next goals are STEM/technical goals, and these include improving the ability to make CAD, because CAD is a very hard part of FTC, because to be able to learn how to use the software and really integrate it into your season takes a lot of practice and a lot of time to learn that. Next, we want to integrate new modules in our programming, and that just helps with accuracy for functions in a robot, especially related to new math and physics concepts. And we want to just enhance our STEM skill set in general. And we want to make sure our robot is structurally sound. And we want to make sure that our robot has great programming. Next is professionalism. We want to use active listening and respect all views in discussion. So we basically want to value that listening is a very important thing, and we also want to be organized and maintain gracious professionalism on and off the field during our competitions, which is basically just being kind and respectful. And we also have a clear agenda and a prioritized task list for every meeting aligned with our team goals. And we make a lot of timelines and make sure people follow deadlines to make sure we can learn as effectively as we can. And we have a simple log of each meeting and a meeting note summary to make sure everyone remembers what to do. And this will help us advance towards our goals. All right. And
okay. So sustainability is really important for our team, because not only is our creativity and just building the robot important, but we also need the funds to make that. One way we get the funds is sponsorships. We work with a lot of sponsors, and these include Polymaker, Microsoft, Digitech Labs, and we're working to get more and more sponsors as we go. But cost and budgeting is really important, as we need to buy a lot of parts from, for example, GoBuilda is one place we get our parts, and these parts actually take a lot of money, and because of that we have to manage our money really well, and we can't just waste money on parts we don't need or are not using. We make Excel spreadsheets of parts, exactly the parts we need, and send it to our coaches for them to check it, and then we budget our money and do our operations like that. But yeah. So as our season evolves, our game strategy also evolves. And our game strategy is really important because we need to know how to approach the problem, obviously. We can't just rush in. We need to actually analyze how the problem is forming and the best way to actually approach it. And a lot of the times, there's like a unique way of approaching the problems that we didn't think of. So finding out a game strategy and using different game strategies is really important. The game strategy can be the difference between winning and losing. But our initial strategy is for the last season is, since our challenge was shooting, we decided to shoot close from the classifier, and in front of the classifier is what we call the hoop, basically. And we decided to shoot close from the hoop. But after LMO, which is like a competition that we went to, our new approach is we changed our robot design, and using our robot design, we changed our game strategy. And as our robot evolves, our game strategy is also evolving and changing. So that's just how our game strategy is really important. Okay, so our engineering process, I touched up on this a little before, but our engineering process, there's 5 steps to our engineering process. First, I'm just going to review it again. First, we define the problem. As you can see on the side, we use like a whiteboard in our meeting because we actually meet in one of our friends' basement, and we use a whiteboard to like go through what's our agenda for today and what's the problem we want to face. We draw like small sketches and diagrams on here, and every meeting in the beginning, we walk through the whiteboard to see who's working on what and what's our plan for today, and this helps us stay organized. So first we define the problem, then we brainstorm, and our brainstorming can be really rough, just like a small whiteboard sketch, but it also can be like a complicated CAD. It's just depending on what the team prefers. And then we CAD and design, but CADing is really beneficial just in robotics. There's multiple platforms you can use. You can use Onshape, you can use Fusion 360, but CADing is really important because not only does it help the team visualize a robot before they build it, because building and drawing it on a whiteboard, there's such a big gap, and CAD fills that gap. But also a lot of the parts that we create are 3D printed or designed by ourselves and are not bought, and CAD's also really beneficial for that. But we also build and test, as you can see here, this is a rough testing of just an intake on our drivetrain. We're just testing how that intake design works. In our previous robot, our intake wasn't working really well. It wasn't gripping to the balls. And then we had the idea of wrapping rubber bands around our intake. And this worked really well because the rubber band could latch onto the balls and grip the balls really well, which improved our intake speed. And this is just one way of how building and testing can be really beneficial. And then iterate is just evolving our robot to be better and better. So as you can see here, we evolved our flywheel. This is a transfer that pushes the balls forward to our shooter. And it started from just like this 3-fan type design. And then we made it thicker because it wasn't latching onto the balls. And then we realized we had to, the crescent moon shape was actually really unique for us. And it was actually better because we had a problem of jamming our balls because we had 3 balls at the same time. And this crescent moon shape kind of removed the jamming problem. So that's also another way we iterated. Okay, so our season progression is just walking through the season. Our robot obviously evolved a lot. A lot of teams have like different robot designs. They usually don't stay with the same. This year whatsoever, the starter robot that first provided for us was like a lot of teams use that. But usually in most seasons, in most competitions, the robot evolves a lot, and you can't even recognize it from the competition before. But every time we make a robot, there's like strengths and weaknesses. And as you can see here, the strengths and weaknesses, there's slowly there's more strengths and less weaknesses as the season goes on. And that's just basically what we want to do. We want to make our robot as good as possible. We take our first iteration, go to the competition, see what's wrong, and then in the next iteration, we try fixing as much problems as possible, and then we just keep going and going.
All right.
So
Oh.
like for example, one part of our robot was the shooter. Our shooter was to propel the balls forward into the basket. As I said, we're shooting balls into a hoop. So this helped us propel. And there's just different iterations. We first started with like a ramp shooter over here. And then as we went down, we went to a double shooter up to give more power. And yeah, we just evolved. Our intake also improved a lot. This is our ramp design and our side. So we have like side plates that help reel the ball in, and these are the side plates. They're like low corners on the front of a robot, and then there's also the intake design, as we said before. And these metal rods are supposed to represent the rubber bands that we use. As I said before, that it's really grippy. The rubber bands are grippy, so we use those. And then this is a transfer design. Our transfer was actually really important for us since I would say like it's the one we had like the most issues on. We did a lot of ball jamming, and this caused our transfer to go through a lot of iterations. I'm not going to list all of them, but you can just see how much iterations we went through, just testing and iterating. And yeah, it's just our robot has been changing like throughout the season.
Yeah, to speak a little more about our transfer. So we started with like different types of transfers. So like we also like tested a lot throughout the season. But like this is just like what worked for us. Like a lot of the prototyping was like it's not like documented here, but this is just like the progression of what we did throughout the season. We also experimented with different filament types. So we tried out TPU, PLA, PETG. But our final transfer here was printed using PLA. Yeah, so now to get into more of the software. Last season we used Next FTC as our main command base. It had like simple FSM logic to schedule commands, but most of it again was command based. Then also one thing we also utilize is panels dashboard. A lot of like FTC teams use either FTC dashboard or panels dashboard to view live telemetry, and it also shows your robot's movement during autonomous mode on the robot graph. And it's also really helpful to debug server positions and tune velocities and to tuning PID controllers as well, because all the telemetry is live. And then pager pathing is a reactive pathing follower library, which again uses Bezier curves, and it also has built-in PIDF control. And then yeah, we also use it in teleop because it has built-in centripetal force correction, which is it makes our turning faster. And we also use something called field-centric drive. So usually with a robot-centric drive, like the robot's movement is relative towards the robot itself, but in field-centric drive, the robot movement is relative towards you, where you are in the field. And then Pager is also good integration with Next FTC, and we also try to optimize our pathing, as you can see over here, to try and score as much as possible during autonomous. And then we also use embedded custom PIDF and like a low pass filter on top of that. So because we were getting like a lot of oscillations when it came to our velocity PIDF, we decided to just add a simple additional low pass filter on top of that to smooth out all the oscillations, which is high frequency responses. We also did this by averaging out past velocities with the current velocity and feeding that as a velocity set point for the PIDF control loop. And our mentor, Ruchit, he explained how like the additional low pass filter would help, and then we developed it. More software stuff is we also had a Limelight camera here. First robotics competition, FRC, also uses like Limelight, but their Limelight is more fleshed out than the one allowed in FTC. So to make it easier on our drivers, we use the Limelight 3A camera to detect like the April tag or fiducial, as you call it, on the classifier, which is the place where you shoot balls into. This is like an example of the pipeline camera stream from the Limelight. As you can see, it can detect the April tag from a pretty good distance out, which is good. And again, we followed like the normal engineering process or software design process for this. The drivers take too much time to position the bot. That's like the problem that we had. So then we either could use like a webcam or Limelight. We found that Limelight was definitely easier to implement than a webcam. Also, like the functionality of Limelight is that it has like so much more functionality, so it'd be way easy, like way more beneficial for us to choose Limelight over a webcam. And then the biggest thing we did was we implemented a custom cabin filter sensor fusion using the Limelight. Because as we found is that during a match we we had like a lot of like pose estimate drifts from our dead wheels over here, our odometry pods. So what we decided to do is that we wanted to add like an automatic parking feature at the end of the match. So you get extra points for if you park like inside an 18 by 18 sized square at the end of the match. You get extra points, and we wanted to automate that like anywhere on the field. So we decided to use a custom cabin filter sensor fusion for like the pose, so that because the match is about 2 minutes, so our odometry pods we get a lot of error because of drift. So what we did is we fused the Limelight camera's pose estimation with the odometry pose estimation, and then we just tuned that, and then we got a pretty good estimation about where our pose is. And then for everyone who like doesn't know what a cabin filter is, essentially what it does is that it assumes that every state of the system is along like a normal distribution or a Gaussian distribution. And then it's used to predict the system state because it's assumed that all the possible states fall under a normal distribution. Yeah, and then we use over here, you can see like the Limelight field pose with respect to an April tag. So if we know where the fiducial is, and we know where our robot is with respect to the fiducial, we can compute where the robot is on the field because the fiducial is in a fixed position. Yeah. And then this is getting into more of our outreach. So our outreach is again, it's tailored towards younger kids, getting them more involved with STEM because we want STEM to be more impactful on their lives. So inspired by we actually did an outreach last year, and inspired by the outreach, a few girls from the school district joined FLO and FTC teams, and they were able to actually win an award. So when the outreach we did last year was the Redmond Elementary School Science Fair. We went to an elementary school. We showcased our robot, and then around 30 kids actually said they were interested in learning more about our robot and about FIRST. We also hosted a robotics workshop in the Redmond Library, and then 15 kids were interested in starting with FIRST. And then our biggest outreach we did last year was we actually flew to India, and we went to an underprivileged school. And we gave around 400 students a new opportunity to explore STEM, and we developed a curriculum over there, and we introduced STEM into their curriculum, and like it's changed a bunch of kids' lives over there because they don't have like the amount of money their parents earn is like our parents probably earn like a week what they can earn in like a year. So it really opened up a bunch of doors to us and really inspired them. We also had to overcome a complete language barrier. Because again, we're all from the different places, so not everyone like knows the language they spoke at that school. We did sessions about 1 hour for 5 classes, and we even got this like really big quote where a student said that I now dream of becoming an engineer. So we had immense impact, and yeah, we're also continuing in India outreach this summer as well. Yeah, so that's like the biggest highlight of our STEM outreach we've done. Flying international was just like it was a great experience for all of us to be able to see how much impact you can actually have on underserved communities. And then, of course, we want to give back to our home as well. We're all based in Redmond, so our team partnered with Green Redmond, and we've done a bunch of volunteering activities with Green Redmond, cleaning up at Meadow Park. It's very local to us, to where we all live in our area. So we went there for a few hours. We helped clean all the blackberry bushes there. And then we also helped out FTC Washington as a whole by handing out business cards so that more teams can get access to the FTC Discord and ask questions about robots, outreach, non-technical and technical skills. And then we've also connected with other teams as well. So again, our sister team, Bond Not Found, we've hosted multiple scrimmages with them and we've also exchanged parts just to be nice and to create new connections. We also helped Bot Not Found start Bot Got Found, which is a rookie team, and we helped them test their robot. We helped them with the programming, their engineering portfolio as well. We've also helped Penguins in Disguise give tips on how to conduct successful outreaches, and we've also given them guidance on a bunch of FTC concepts. Our last connection that we had was with Technova, which is a team that's qualified for Worlds in Tennessee. They helped mentor us for a little bit, and they gave us some crucial information about designing, planning, and brainstorming shooter ideas for this season.
All right. So this is mainly about our industry connections. So like I said earlier, industry connections are one of the ways that we want to connect with our community. So first, we did an industry connect at Meta Reality Labs with Vijay, who was a research scientist there. And he showed us how SLAM, which stands for Simultaneous Localization and Mapping Computer Vision, is used in their new Project Aria AI glasses. So he shared valuable insights, and we learned a lot about how we can use AI computer vision, which uses cameras, which is very important for us because I feel like that's the next step for our season, because we want to improve in CAD, but we also want to improve in the automation. So like Soham was talking about, parking our robot in the 18 by 18 square at the end, or a bit bigger. So AI vision is very important for that, and we can kind of automate that to make sure that it has precision. So next, Dilip, the head of a cybersecurity branch at Microsoft, shared his expertise on AI agents, and he taught us a lot about large language models, which is how pretty much all AIs are built on. And he also taught us stuff about agent workflows and retrieval augmented generation, which is RAG. And he showed us how AI agents are used in industrial robotic applications, like in the Amazon fulfillment center. So speaking of that, we visited that Amazon fulfillment center, where we received a tour showcasing how robotics is used to transport, package, and sort items. And seeing these systems in action gave us like a very clear understanding of how robotics is used in the real world and how it makes so many things so much faster. And that's actually a very important part of the Amazon fulfillment center, because it is like largely dependent on these huge robots. All right. Next we have our team visited the Microsoft Garage to explore the variety of industrial tools available there. Sriram, a knowledgeable Microsoft employee, guided us through the building, and he explained the function of each piece of equipment. So he taught us how to use a laser cutter, and he also showed us the amounts of 3D printers there and what we can use with them. And the pictures all below are of these connects. And then next we have our logo design. Our logo design, although it may seem unimportant, our logo design was done with the guidance of an industrial graphic designer. So we also learned about how to make ourselves appealing. So she helped design our logo to make it clean, but also look meaningful and show our team. The colors represent our team because they show energy and radiating positivity. And the lightning bolt represents energy and the passion to learn. So our mentor connection. So Ratchet, a Bosch employee, became our mentor through his industrial connection. His expertise in math, physics, and robotics directly shaped our robot's design, and he really helped us with tuning our robot and making sure it was ready for the competition. And we also have sponsors, and those are displayed there.
Yeah, we also got an additional sponsor this offseason in Numerous. I'm pretty sure they did a presentation here too, but yeah, we got them, and they're going to be a sponsor for us next year as well. Sai, do you want to take this?
All right, yeah, sure. So online connections. So our team has many online connections to social media, and the social media is a great place to reach out to teams because we don't have to spend a lot of effort and time going to physical places, and we can talk to anyone and communicate with anyone just online. So our team has a YouTube channel to model our progress and allow audiences to engage in first robotics related videos. And what a lot of teams do, including us sometimes, we go on YouTube and we look for FTC teams that are and we look at their designs for this season and see how we can use that as inspiration. And we got featured in a popular FTC creators video for our innovative designs, and his name is Brogan Pratt. So that also spreads our reach further. And so far, our videos have helped us connect with over 9,000 people, and that's probably only increased because this is a bit old. Next, on the FTC Discord, we have helped over 45 teams, rookies as well as veterans, and we post our season progress there and answer any questions. And we have helped teams engage with questions related to software, hardware, and engineering portfolio matters. And on Instagram, we have connected with over 500 people from different teams via Instagram, and we post our innovations, our season progression, and we post thank yous for our sponsors, and we collaborate with teams using Instagram. And yeah, we actually collaborated with a team in India through Instagram, I believe. So regarding the people reached out, through our outreach, about 200 people, Instagram about 550, YouTube 9,000 plus, and GitHub, which is where we put all our code, about a bit over 60, and Discord is about 370. So a total of 10,000 people reached a bit, and this is a bit old, so we've only reached more now.
Yeah, that's it for our portfolio. If you have any questions, you can ask us or put it in the chat.
I'd like to hear a little bit more about the feed forward part of your
Yeah,
control system, if you could talk about that.
yeah. So of course, we have a base PID, proportional integral derivative controller. But on top of that, what a lot of teams incorporate is a feed forward. Usually it's just, so how it works is that if you have like, let's say a robot and you're trying to tune like, let's say like a heading PIDF. So a controller that controls the heading of your robot independently. You would up the feed forward to a certain amount until your robot starts shaking. So you're pretty much adding extra like power that it'll put in on top of the PID, which will help make everything more consistent. That's how it is used in drivetrains, but we also use it in like, let's say if you have like a linear slide application, you want like a linear slide as in like it goes up and down linearly. You would want that type of feed forward that counteracts gravity because you don't want gravity to be a factor in your system.
So can you give me an example of like what are the inputs and outputs of the feed forward part of that?
Yeah.
Like how is it tuned?
Yeah. So your input would like while you're tuning it, you input like the value of what you want the feed forward to be constantly. But the actual input would be extra power onto the motor or set the motor to, like a base speed that it will always be at. And then it'll add that speed on top of whatever the PID outputs for the speed that it needs to be at.
Okay, so it's like making a guess based on the requested input. Okay.
Yeah, it's making a guess about how much power it has to constantly apply on top of whatever that power the PID generates.
Yeah, I think one example of this would be like, let's say like you have an arm, for example, going up and down. There would be like a gravity constant performing on the arm, and then the feed forward would have to like calculate the gravity constants to be more so the arm can move more precisely.
Right, exactly. That makes sense. So yeah, a good prediction. Thanks for that.
Yeah, of course. Anyone else have any other questions? Okay, yeah. That's it for our presentation, but thank you so much for letting us present. And
Yeah.
yeah, I hope
Yeah,
that everyone
thank you.
got some like insight into like student robotics in general, what FIRST is doing for robotics, what our team has done in the past, and how our team hopes to progress in the future.
And then also thank you. I'm sorry if I pronounced this wrong, but Stephen for putting all the links on what we talk about in the chat. If anyone had any questions.
Yeah. So how many of you guys are going to go on to FRC?
Yeah, so Raghav and I are actually on an FRC team, and we're also on FTC teams. We're both on FRC 7461 Sushi Squad. But yeah, FRC is like it's pretty different from FTC. Like because the season timelines are like different. So FRC starts up in January while FTC starts in September. Like you can definitely like manage doing both, which is what me and Raghav are doing.
Yeah. That's a very impressive presentation. You guys have, boy, feel like I'm sitting in a meeting at a big engineering company looking at their explanation for how they're going to pull off some crazy project. You guys, this is really amazing. How many people on your team altogether?
8.
Yeah, this
8.
past season we have
Wow.
8, but currently we have 7.
Currently, we have 7.
Yeah, one of our members.
One of our
moved to
members
us, so.
sadly moved. Yeah.
Wow. Well, great job. You guys put a lot of hard work into that, and it, so how did you do in the competition, or is it?
Yeah, this past year our competition performance wasn't too great because we ended up having a lot of issues with our bot like late in the season. Mostly because what ended up happening was that we committed to like a design a little bit like too late, and then that just caused a bunch of issues throughout the season. But yeah, this summer we've been like making a lot of progress on like off-season robots and learning a ton of new skills. So we hope to do like way better next year when it comes to competition, and as well as expand our reach in our community and further.
Yeah. Well, I know that the community outreach is something that the SRS here we there's a number of members of the SRS that mentor teams, probably mostly FRC, but there might be a few that do some of the younger teams. And then you talked about going downward. Let's see, what is it? What do they call it? The one below FTC.
FLL.
FLL. That's
First
right.
Lego League. Yeah.
Yeah. So one of my sons did that when he was like 10, 9, 10, something like that. Yeah. And wasn't really quite his particular calling, although he's still in a technical field. It's just a little different direction. But anybody else got any other questions? That's wonderful presentation. Wonderful presentation.
Thank you so much.
Thank you.
If you don't mind, if one of you could send me the slides?
I can email slides and our portfolio.
Okay. How about can you make them PDFs? Turn them into PDFs before you send them?
Yeah.
Okay, that would be awesome. Yeah, and then we'll put that in our post. That'd be wonderful.
Thank you.
So anybody else got any questions to baffle these guys?
I'm curious if the kids that you were working with over in India and other places, you talked about like recognizing the limitations that they face. And I'm just kind of curious if you like once you were able to present them with a curricula that avoided those limitations or helped to get around them to some degree. Did you see like a real reaction from them? And I guess what I'm trying to get to is like, do you see in people in the United States, especially in other students in the United States, like a lack of understanding of what their opportunities are compared to what those kids in India saw?
Yes.
The reason why I'm asking this is because I hear a lot of like hopelessness from students in the United States. And I think that your experience with how bad it was there and how much they're willing and able to improve from a little bit of help might help to get some of our kids off their butts and starting to learn. Sorry.
But yeah, I wasn't even at the outreach, but I did help translate a lot of audio recordings. And yeah, I see like a huge difference because the kids in India, they took this as like an eye opener. They didn't even know that this technology existed. They didn't know they could do this. And based on our presentations, they drove around the robot, and it was like a real eye opener for them. So like maybe other kids in the US, maybe they've seen these robotics because the US usually has a lot more robotics than in India, especially in the rural parts of India. So yeah, like there, based on the audio recordings, there was like a genuine reaction that they really dreamed to be an engineer, and I think that's like a life-changing moment that sparks passion, because once you've got a person with a passion that big, they really make their whole life tailored towards that. Whether that's leaving everything, sacrificing so many things. If I think that spark of passion based on those audio recordings, they said that with like a very true voice. So yeah, I think that's the main difference. I think we really sparked a passion, and they wanted to become better. And that's what I really saw there.
How do you have any advice for how to reach kids in the United States, I guess?
Yeah. Honestly, I think for kids in the United States, one thing is just like getting like, you know, like the thought of like robotics out there. It's not just about, you know, going to like some place and just like giving a presentation to us. It's like, you know, we're actually spreading like a message, you know, a message like go try out something new, try something out, see how you feel about it. And it's one thing that like, you know, we've been doing here, like in our robotics team, you know, we've been trying to like look for opportunities. We just try as much as possible because like we want to be able to, you know, give kids these opportunities.
One other
Is
idea.
that how you got into it? Oh, go ahead. Go ahead.
All right, one other idea. So basically, let's say the kids, they have like a certain problem in some area that they want to fix. For like, let's say for example, they want like a phone stand. So instead of just buying them a phone stand, what you can do is you can try and make them make their own phone stand or something like that. And this is actually one of the onboarding things we did with our team, is where we made everyone CAD a phone stand for their phone to kind of get them that interest in CAD. And so I think that's a great approach to kind of making them solve their own problems, so they can actually like see that this is useful, and they can actually see the use instead of just looking at other people do it.
Yeah,
I
and
love that, and like seeing that they can do it, like enabling them, and then letting them have the pride in something that they've actually done.
Exactly. Yeah.
yeah,
And I think it all just comes down to interest. You can't like force a kid, whether it be in India or in the US, to do something they don't want to do. Like, for example, let's say like a kid in India, even if we showed them all the robotics, previously the door to FIRST and robotics wasn't open for them. But even after we opened them the opportunity, a lot of the kids weren't actually interested in it, and we can't force them to do anything. Just like in the US, a lot of the kids have experienced like what robotics is. Maybe they've tried it, and a lot of them don't have the interest in it, and there's nothing to force them. The only thing we can do is just say like, here's the opportunities, here's what it is, and then just do. If you want it, you can do it, and here's how you do it.
That's a great point. Thanks for saying that.
But yeah, that was a good question.
So is that how you guys got introduced to this? Is that how you were all like brought into it? Was like through like the former team members giving presentations, or how did you actually get interested in it?
yeah. So Sai and Raghav actually joined the team late, like a year after it was created. But I was like on like when the team was created, like I was first on the team. And before like, you know, Crash Out was created, we were actually an FLL team for a few years. And like how I personally got into robotics is that like honestly, like my parents just like pushed me to do FLL, and I was like, okay, fine, I'll try it out. And then I ended up like liking it a lot. And
Yeah.
then
Yeah,
after
a
that,
lot of times that's it. Yeah.
yeah. And then I ended up liking it a lot. So then after that, after our team became an FTC team, you know, there was a lot of learnings to to learn. And our first year, like it wasn't good at all. But after that, I started realizing like, wow, like FTC is actually something that's really cool. The comp is cool. Like whatever you're doing is pretty fun. So that's when I started, to get more interested in what FTC actually is, into robotics itself and in general.
So I actually teach classes for UCSD extension, not UCSD, for like high school students with robotics. And I have a quiz right on like the first couple of days where I ask them like, like, why are you taking this class? And it's like the options are like, it was a personal interest, or it was because my parents made me, or because like I had nothing else to do, or whatever. I have all these different options, and the most common one is those two together. It's my parents made me, and it's also an interest of mine. And so I think it's important for families to like push their kids to try things, not necessarily just to try robotics, but just to try like a wide variety of different things.
Yeah, definitely. Yeah.
Cool. Great presentation, guys. Thanks.
Thank you so
Thank you.
much.
Thank you.
Yeah, if there's not any further questions, we'll probably like drop off now. But thank you so much for giving us a chance to present, and we hope to connect with SRS more in the future and just learn more about robotics in general.
All
Thank
right.
you so much.
Yeah.
Thank you.
Yes. Thank you so much. All right. So you could just send the slides to the Seattle Robotics Society at Gmail.
I did. Yeah, I did.
Okay. Awesome. Thank you. All right. So we got anything else for these guys before they get back to work? All right. Well, thank you so much. Yes, this has been great fun. Great fun.
Thank you. Bye-bye.
Thank you.
Yep. All right. Well, that was great. I love hearing that. I love the enthusiasm of these young people for what they're doing. They're all obviously very excited about what they're working on, and I their passion even to reach out to younger kids and to reach out to peer kids that try to draw people in to what they're doing. It's it's awesome, and this robotics is a great tool and for really getting young people interested in doing something that matters, something interesting. So, well, we are about 12:15 almost. So, thank you guys all for showing up again. And okay, you have to keep an eye on the website, the SRS website, see if I manage to put anything in there for next month. But so. I hope this was an enjoyable meeting for you, and I look forward to seeing you guys next month at this meeting, and then hopefully the week later at Robothon. So, all right, you guys all have a good one.